Welcome back to Wages and Employment at Wilfrid Laurier University. Today we are continuing with our basic labor supply model by building our potential income constraint. For reference, you should pair this video with readings in Chapter 2 of your textbook. I want to start by reminding everyone of the story that we're building here. In the last video, we framed how people gain utility, their happiness, from the consumption of goods and services and their leisure time. Now in this section, we're looking at what stands in your way of having everything you want. In other words, your constraints. In the real world, people face many constraints that limit their opportunities in the labor market, but we're going to focus on the simplest constraint that affects everyone. There are only so many hours in a day, and there is absolutely no way to extend that. Now, why is time the most important thing? First, it sets a limit on how much leisure we can enjoy in any given day, but it also limits how many hours we can work for pay. Because we need to work to earn an income, this time constraint effectively limits how much we can consume. What we're going to do in the next slides is build a budget constraint to capture this. Now here's the pieces that we're going to put together. We start with having a simple consumption bundle that has one price. So P is the price of consumption here. The value of the consumption bundle is then that price times the amount of consumption that you're buying, but we're going to let that price equal to 1. It's a simple normalization. We could do this many different ways, but it really just takes it out of the picture and makes things simpler for us to work with. We're also going to have YN. This is any non-labor income that comes into our household that we get to enjoy and spend. This is anything that you don't have to work for. H is the number of hours that a person will work, and this is going to be the difference between their total time endowment, T, and L, the number of hours that they spend in leisure time. We're going to see a wage rate. This is the price of leisure that is given by the market. This is not something that a person has control over. It doesn't matter that they show up at the market, they see what's being offered. So that's the wage rate W. And with that, their total earnings are going to be WH. So this is the wage rate times the number of hours that they choose to work. Noting that WT is their potential earnings, how much they could earn if they were to work every single hour of the day. So we really have a couple of constraints here that we're going to put together. First, we don't throw away time, and we can't create time. So the hours we spend working and in leisure have to add up to the total time available in that day. Second, we don't allow borrowing in a simple one-period model or any savings. So the value of our consumption can't be more than what we have as income, whether that's from non-labor income or our earnings. Put this all together and include the normalization that prices are equal to 1, and we have our main budget constraint here, which is stated in terms of things we choose, consumption and leisure, and things we do not choose, our non-labor income, our wages, and the time endowment. Now you can arrange this to show that on the left-hand side, the value of everything we purchase, or sorry, that's on your right-hand side, the value of everything that we purchase, both our leisure time and our consumption, has to be less than or equal to what we are endowed with. That is the value of our time and any non-labor income. Now, we bring this into the same two-dimensional space that we put our indifference curves in. What we build is a person's potential income for each possible choice of leisure time. On the horizontal axis, we have our leisure time, and consumption, which is equivalent to income here, is on the vertical axis. The time endowment is marked with a T. Points beyond that are not feasible options. If one did not do any paid work so that their leisure time is equal to their time endowment, T, they'd only have their non-labor income available to buy any goods and services. So that defines this first segment of our potential income constraint. But then for every hour that a person works, they earn a wage, and that adds to their income. In the case that they work every hour possible in the day, we see their full income is WT plus YN. What we just built is the most standard potential income constraint. It allows for a full continuum of choices between hours and consumption. But the potential income constraint doesn't have to be that straightforward. So in this example, people have less choice. They can either work full-time hours, which is HF in the diagram, so that their first potential consumption leisure bundle is at point C, or they can work part-time and get the bundle at point B, Or, as a third option, they can choose not to work at all and consume only from their non-labor income with bundle A. Since most workers don't have as much flexibility in their hours as they'd like, this might actually be a good characterization of their options. Now, in this example, a person has full flexibility in how many hours they work, but the wage rate is not constant. Here, it's falling, so that if a person works more hours, they get paid a lower rate. This could be, for example, a person who is self-employed and face a diminishing marginal product of labor. For every extra hour they work, their productivity is lower, and they earn less for that hour. But for our purposes, we are mostly going to work with the simple linear constraint. We are going to see what happens when we change different parts of it by changing the wage rate, as you can see here, or by changing the amount of non-labor income that is available. Though incredibly simple, this linear constraint has proven a very useful tool. So in our next video, we are going to return to the preferences and constraints we've described so far and bring them together to understand the consumer's labor supply decision. See you then.